Okay, so lesson 6 is what we're talking about. And just a little quick review. We have been through the 3 laws, the first law, second law, and third law. All of them pretty much involve the second law, which is F net equals to ma. So you calculate the net force, and then it will have an acceleration. And we would always draw things with the free body diagram. We'd always draw all the forces acting on it, and we would always have and indicators of a general acceleration. And with the implications of the second law, it also leads into kind of the first law. The implication is if F net equals to 0, you also have acceleration equals to 0. And so if the object is not moving or something like that, your net force is 0, there's an implication that acceleration is 0 as well. Okay, and then the third laws have to do with 2 objects and the action and reaction forces. And today in particular, we're mostly going to talk about string. If I have a pulley system and they are being hooked up like this, basically what we're talking about is that, so there's like a little pulley here. If I have an object that's hanging like that, the first thing we have to assume is that the 2 object is stuck together, that the acceleration of the object, say this object 1 is going to go this way and this is going to go this way, we're going to assume that the acceleration of the 2 objects are the same. Okay, that's like a common sense because they're hooked together, right? So the other thing are, if I look at the free body diagram individually for each of the box, say the box to the left hand side, if I call this box right 1, it's going to be feeling a force of tension that's going towards the right, being dragged down from the block that is falling. But at the same time, the other block, if I call this block 2, the block 2 is also going to be experiencing a force of tension that's pulling upward. It's like, oh, somebody's hanging upwards, pulling me upwards that way, dragging. And what you need to know is that the other assumption that we have is because they are the third law, the action-reaction force to each other, these two force of tensions are also going to be the same. Okay, and that's mainly what we're going to be talking about. Okay, so whenever there's a force of tensions, we assume that the rope and string are really light, that we don't consider the mass. We assume that they don't stretch, and so the tension can only pull, and the 2 objects are tied together, so they have to have the same acceleration. Okay, example 1, all the masses are 1 kilogram. Determine the force of tension on each string. Free body diagram. Part A, it will experience the Fg that's going down. Because the question gave me that it is 1 kilogram, I can easily work out what mg is first. So 1 times 9.8. Don't forget, every time they give you a mass, you times it by 9.8. That is your the force of gravity, Fg acting on it. So Fg in this case is 9.8. Okay, so if we finish off the free body diagram, at the same time, the object is experiencing a force of tension that's going up. And because the object is hanging there, the acceleration is 0, meaning it's a first law types of question. There is not going anywhere. So if I were to do the F net equals to ma, acceleration is 0. F net is up minus down. Ft minus Fg equals to 0. So if I were to solve for Ft, I can rearrange. I know Fg is 9.8, right? So I can rearrange the equation. I know that the Ft has to equals to Fg. All I did is I brought my Fg to the other side by adding. And then so Ft also is 9.8 Newton, but this time it is pointing at a direction of up. Now, second part. Now this object is on a pulley that is moving. Rule stays the same, Fg and Ft. But based on what we learned today, when I have the same string, so if I were to say the same string, I am really talking about this string with this string. That's the same string, okay? And if that's the case, if Ft is going up, there's actually also another Ft that's going this way, okay? And because of the third law, these two have to be the same. So if I were to follow the calculations, if I study the free body diagram, the FG and the FT, the acceleration is still 0 because the objects are just hanging there on the wall and then hanging downward with the block that is coming down at the bottom. So if I were to figure out FT, that's what the question wants, right? They wanted to calculate what is the force of tension. And so I would repeat the same process. F net equals to MA. The A is 0 again because the object is not going anywhere. And to find the F net, I would go FT minus FG, the two forces that are acting on each other. So up minus down equals to 0. Same thing as just now. FT would equals to FG, and because it is also 1 kilogram, it is also still 9.8 newtons. Okay, the question is, what direction do I write for the FT? If I'm talking about the FT that is right here, like this FT right here, then it should be up. But then don't forget, just now from the lesson, we were saying that this FT is the same as this FT. So if the question asks, what is the tangent of its strength? You actually don't need to write the direction if it could be more than one direction. Okay? And for the last part of question 1, if you kind of put a dotted line, do you see that this question is the same as question part B? Because I have force of gravity, I have force of tangent, I have acceleration equals to 0. So that means FG is 9.8. And then it has to equals to FT, which is 9.8. And because this is going up and this is going to the right, this FT is also 9.8. And then at the same time, on the left-hand side, I have the exact same thing again, because all of the masses are 1. So the FG is still 9.8. Force of tangent going up, force of tangent going to the left, and the acceleration is 0. So you know what? Every single FT is equals to 9.8 in this question. Question 2. 3 sleds are tied together and pull east across the icy surface with an applied force of 120 Newton to the east on sled 1. The mass of sled 1 is 12, sled 2 is 11, sled 3 is 7. You may assume no frictions. First question. Determine the acceleration of the sled. All of them together. Okay? We have everything all stuck together. And so for the part A, you can almost treat the whole system together. So I have all the masses together for the sled. The forces acting on it is basically going to, I'm going to just draw the dot here, the free body diagram. We have an FA. It has a force of gravity and it has a force of normal. The acceleration is towards the right. So to find the actual acceleration of the object, I know that F net is equals to MA. And F net in this case, I only have one force. I'm studying the motion along the X. F net is just FA. I only have one force because they told me to assume that there is no friction. Okay, and then M is the total mass of everything all added together. So all the masses together and then solve for your A. So the FA in this case is 120 times the acceleration, and then divide both sides and solve for your A. So 120 equals, so if I add up all the masses, they should be 30 times A. So rearrange the equation for A. A worked out to be 4. Check number of sig digs. There should be 2 sig digs, so I'm going to put 4.0 meters per second squared to the east. Part B, calculate the magnitude of the force of tangent of the tension in the rope connecting sled 2 and 3. So that means this time I'm going to have to draw free body diagrams separately for each of the sled. Okay, so sled are connecting like that. And because the forces are going to the right, I am going to call this sled 1, sled 2, and sled 3. Okay, for sled 1, let's just see, I wanted the magnitude between sled 2 and 3. So basically, I need the force of tension between this 2 and 3 right here. This is what I wanted to find. So I'm just going to draw the diagram, okay, and just see what they look like. So free body diagram for number 3. Oops. I have FG. I have Fn because it's sitting on a surface, and I have a force of tension. This is the rope, Ft. This is called the Ft. This is between 2 and 3. Okay? So I could use that. Right now, I found the acceleration. I know the acceleration is going towards the east at 4. Okay, so let's analyze this. So F net equals to MA, right? And the net force in this one is Ft between the 2 and 3. I'm just going to label this Ft 2, 3. Okay, so that's the force of tension between 2 and 3. It equals to M, the mass. I'm studying object number 3, so I'm going to use the mass of the 7K. Okay, and then I know that the A is 4. So Ft23, force of tension between object 2 and 3, it equals to 7 times A, which is 4. So this worked out to be 28 newtons. Is it to the east or is it to the west? It's hard to say because I asked you the tension between 2 and 3, but you could also be looking at this one that's going to the west. It's the same, right? Because there are the action reaction force. So that means in this case, we actually don't write the directions anymore because it could be going to the east or the west. So we're just going to leave with no directions. Part C, we're now to find the force of tension between 1 and 2. So I need to either find this Ft between 1 and 2 or this Ft between 1 and 2. So it's either way, whatever you want. So I am going, it doesn't matter, okay? Pick 1 or 2. I'm going to do both. I'm just going to quickly show you both. If I pick the first mass, okay? I know the mass for the first one is 12 kilogram. I know that the free body, I just want to redraw it so it's more clear to you. I know that the Fa is going to the east, and I know that the Ft12 is going to the left, to the west. I have my Fg, I have my Fn that's going upwards. My direction of acceleration is to the right. So to study the F net, it is equals to Ma, and F net, in this case, I got two forces, right? I got one to the right and one to the left. Because the right-hand side is the direction of the acceleration, that becomes my positive side. So my F net is Fa minus my Ft12. It equals to the mass times A. I'm going to plug in the numbers that I know. Fa is 120. That was given in the question. Ft12 we don't know. I know the mass for block 1, which is 12. And I calculated the acceleration to be 4. So if I were to rearrange the equation and solve for this, so I know that I need to bring this over by subtracting, and then I can bring this over by adding. So Ft12 is going to be 120 minus 48. Solving for Ft12, I am getting a result of 72. Okay, same thing. I don't know if it's to the left or to the right because it's the same for both sides of the Ft. So this is if I were to choose to use block 1. But what if I repeat the question? You don't have to. You can just do it one time. But I just want to show you that it is the same. Okay? If I were to redo this question for block 2, I know the mass of block 2 is 11. And block 2, look at block 2, right? Block 2 is this picture right here. Block 2 have a forward force of Ft12. It has a backward force of Ft23, Fg, and Fn. Studying the net force along X, F net equals ma. The net force this time has 2. I have forward, which is the Ft12, minus the Ft23 equals to ma. I don't know what Ft12, but I already saw for Ft23 just now in part B. And the mass is for block 2 because that's the object that I'm studying. So it's 11 times the A, which is your 4. And if you punch it in the calculator, so 44 plus 28, you're going to end up with Ft12 also being 72 Newton. Okay, so just know that there are different ways that you can solve for it. As long as you're careful, if your free body diagram is for whatever that object, that's the mass that you'll be using, then you're good to go. Example number 3. 2 masses are connected over a pulley as shown. When released, they accelerate. Assume the surface is frictionless. They want you to calculate acceleration and tangent. For this question, I would like you to assume that there is 3 signigs. Okay, so just a little bit recall. At the beginning of the lesson, we talked about every time when I'm having the same strain, there is an assumption that the FTs are the same. So for the same strain, we can assume that the FTs are the same. Okay, and then the other assumption is because the objects are tied together, their accelerations also have to be the same. Okay, so the accelerations are same for both objects since they're tied together. Okay, so we're going to draw the free body diagram. We're going to draw them very carefully and clearly. So format is what you need to get used to. I'm going to call this block 1. And I'm going to call this block 2. Okay? So block 1, M1, has a mass of 30 kilograms. See how I clearly write my mass about the free body diagram, so I know that I won't make a mistake and use the wrong mass in the equation. So this object has a string that is pulling to the right, and the FT is what is pulling it. And because there's only one string, like we don't have it like, the other one, I don't have to say FT1, 2 or whatever. I just have one FT. It's sitting on a surface, and force of gravity is pulling it down, and force of normal is pulling it upwards. The direction of acceleration is towards the right-hand side. Please have common sense, right? Like if the object is hanging kind of on the side, you know that the object is going to be traveling towards the right and down. Okay? I'm going to change the color just so that it's color-coded for you. I'm going to call the 10 kilogram the block 2. Okay? Block 2 is 10 kilogram. And the free body diagram for block 2, I have an object, force of gravity is pulling it downwards. Because it has a string, it is pulling upwards in the FT. Direction of acceleration is going to be downwards. Okay, so the first step is, like always, you draw your free body diagram. Second thing you need to do now is draw your F net equals to MA. So I'm going to study the forces along the X. F net equals to MA, so I'm going to write that out. F net equals to MA. And in this case, my F net, I only have one force that are going to the right, and that is my F net. Because I only have one force, the net force is that force. Okay, so I have FT equals to MA. I don't know what FT is, I don't know what A is, but I do know what M is, so I'm going to plug in my mass, which is 30 kilogram times A. Are we good? Okay, I'm going to do the same thing for block 2. So block 2, in this case, my forces analyzed has to be along the Y direction. I only have forces that are going along Y. F net equals to MA. The net force, because downwards is my positive, I take my positive, I subtract my negative, right? So the net force in this case is Fg minus Ft equals to MA. I can solve for my mg because I know it's 10 kilogram. So it's 10 times 9.8. So I have 98 newtons to be what Fg is. So 98 equals, 98 minus Ft equals to m, which is 10 times A. Right now I have two equations with two unknown. This is equation 1 and this is equation 2. Because I have two equations with two unknown, I can do substitutions and sub one into another. So now what I'm going to do is I'm going to take Ft equals 30A and I'm going to sub it into this Ft. So 98 minus, instead of writing Ft, I'm going to sub in that Ft also equals to 30A equals to 10 times A. Bring this over by adding. So 98 it equals to 10A plus 30A. I'm trying to collect my like terms. So 98 is equals to 40A. And so rearrange the equation. A worked out to be 2.45 meters per second squared. And then finally, when I found the acceleration, and if they want you to calculate Ft, you can just plug your A into either equation 1 or 2, and then solve for your Ft. So equation 1 looks like the one that I'm going to be using. So Ft is going to be 30 times A, meaning 30 times 2.45, and this worked out to be 73.5 newtons. And as we said before, the directions we don't have to write unless the question specified, oh, find the acceleration of the 30 kilogram block. Then you have to put the acceleration. But if they didn't specify the object and it could have more than one directions, you don't write the directions at all. Okay? Okay, this question is not on your package, but I wanted you to give this a try. So I got two objects that are hanging on a pulleys. And I'm telling you, one is 4.5 kilogram, one is 2.8. I would like you to find the acceleration and the force of tension. So let's just review the steps. Okay, number 1 is you draw your free body diagram separately. And don't forget to assume a direction of acceleration for each of the block. Remember, exercise your common sense. Okay, number 2 is you would then write out your net force equals to MA for each. And then you're going to plug in everything that you know, solve as many things as you know, and then the last one is you have two equations with two unknown, and then you solve for them. Okay, you would use your math. Remember to be legal on your math, right? So do your substitution properly. Make sure, if there's a negative, you be careful of it. And then you solve for the A and the F. Okay, I want you to pause this video right now. Do it on your own and then come back and watch it. Okay? Okay, so welcome back. Hopefully you did your math. I'm going to write the answers down for you, and you're going to check. Okay, I calculated the acceleration to be 2.3 meters per second squared. No directions, because it could be up or down. And the force of tension, I found it to be 34 newtons. Okay. All right. So I'm glad you did it. I hope you did it. If you didn't, here's a walkthrough of it. But I really do want you to try. When I go through an example, just like in class, you need to try it out. Don't just watch, right? Okay. So follow the instructions. I'm going to have mass 1. I'm going to use a red color. Okay. Mass 1 is 4.5 kilogram. Mass 1 is the object that is on the left hand side. If I take a look at the common sense of the picture, if it's a 4.5 on the left and a 2.8 on the right hand side, does it make sense that the acceleration has to be going downwards for the heavier block and upwards for the lighter block? Okay, so if I were to draw the free body diagram, I know that it has FG and FT. FG going downwards, force of tension is the rope that is hanging upwards for the 4.5 block, and I know the acceleration is going downwards. So for me to write my net force equals to MA, my second law, F net equals to MA, because downwards is the positive, I go down minus up. So that means I go FG minus FT equals to MA. Okay? So to work out the mg, the fg, remember to times it by the mass. This is because it's block 1, 4.5. I'm going to work out 4.5 times 9.8. So it worked out to be 44.1 newtons, and that's my fg. So that means I can plug it into here. Equals to the mass, which is 4.5 times A. Then basically the next step is you decide how you want to do it. I know I'm looking ahead that I have two equations with two unknowns, so I want to get the work by itself. So what I'm going to do is I'm going to isolate the ft on its own. So I'm going to, because there's a negative in front here, I'm going to move the ft over there by adding, and I'm going to actually bring this over to the left. So 44.1 minus 4.5a is equals to ft. So that's my equation number 1. I'm done with block number 1. And then I'm going to repeat the process for mass 2. So mass 2, in this case, I'm going to clearly write my mass at the top. Step 1 is the free body diagram. I have force of gravity that's going downward. I have a force of tension. And don't forget the direction of the acceleration is A, going upwards. Because this is a lighter one, it's going to be pulled accelerating upwards. F net equals to MA. The F net, because A is at the top, I have top minus down. So it becomes FT minus FG equals to MA. Since I'm not seeing you, I don't know if you understand why when the acceleration is up, then that's why it's FT minus FG. So I'm going to kind of recap just to make sure you're getting this concept, because this is a very important concept going back to lesson 2 when we talked about net forces. So this is just on the side. Okay, this is just to recall, just to make sure you guys are on the right track. Okay, if I give you a block and I tell you that the object have a net force of 5, a 5 force going upwards and then a 2 Newton force going upwards. If I ask you, what is the net force? You're going to tell me that it's going to be 5 minus 2 equals to 3. Are you okay with that? That's your net force, right? The next question I'm asking you is, which way would the acceleration be? You're going to tell me the acceleration is going upwards. Okay, so that means basically when I'm doing this part of the question, if the acceleration is going up this way, I go up, which is 5, minus down. But in this example, I don't have a 5 and a 2, but the concept is the same. Wherever the direction of the acceleration is, that's kind of my positive force, right? Because it's always the bigger one minus the smaller one, and it's the bigger one that is causing the direction of the acceleration. Hopefully this is a bit more to clear this up. See, so now continuing on with the sample problem, I now have Ft that is going up and Fg that's going down. So Ft minus, I have been kind of doing the calculation for Fg on the side. Another way that you can do it is you can plug in the equation is Fg equals to mg right into the equation, and then you sub in your mass and your g. So minus m, which is 2.8, times the g, which is 9.8, and then plug in your mass. So that's why it's so important that you're careful to list your mass carefully of which one you're working on. Okay, so Ft is 27, so it's Ft minus 27.44 equals 2.8 times A. Bring this over to the other side by adding. Ft is equals to 2.8 A adding 27.44. This is now my equation number 2. Okay, 2 equations with 2 unknown. And because I know Ft and A is the same, I purposely did this so that I can get Ft on their own. So I can say that this part is going to equals to this part and they're the same. So that I can just equate them. Okay, so I'm going to write Ft equals to Ft. Ft from equation 1 equals to Ft from equation 2, because those are the 2 equations with 2 unknowns. So this is basically going back to grade 10 math, 2-point intersection. Collect your like terms, bring all the A's to one side and all the numbers to the other side. So I'm going to put the number to the left, and I'm going to bring all the letter A to the right hand side. Collect your like terms, add them up. So 2.8 plus 4.5 is 7.3A. And then I'm going to work out what the left hand side equals to. Solve for your A. So I found A to be 2.3 meters per second squared. I'm not going to finish the question, but to find out what Ft is, basically you take your A and you plug it back into one of the equation and then solve for your Ft. And that's why I got Ft to be 34.